Welcome to Breaking News to Trading Moves.
Today we're looking at a development that really caught a lot of attention around December 24th. It involves Nvidia, the leader in AI compute, and a very specialized AI chip startup called Groq.
Right, and when that headline first appeared, it immediately brought up a lot of questions. Questions about, the concentration of power in AI hardware.
Mm-hmm.
So for you listening, our goal today is to go a little further than just the initial headlines. We're going to analyze what this arrangement actually is, and maybe just as important, what it isn't.
And from there we'll map out the consequences. We'll identify the companies that seem positioned to gain from this, and on the other side, those that are now facing, well, some new competitive pressures in this whole data center arms race.
Exactly. It's all happening against the backdrop of this big pivot in the market, isn't it?
It is. We're seeing this move away from just focusing on AI model training, the big upfront cost, to optimizing the long-term scalable execution of those models.
The day-to-day running.
Precisely. And this move by Nvidia, well, it looks like a way to fortify their position right at the new center of gravity for AI compute.
Okay, so let's start where all the chatter began. The number that was being thrown around for this transaction with Groq was, frankly, huge. Something like $20 billion.
It was. A number that big immediately makes you think full acquisition.
Of course. At that price, it would have been one of the largest deals in AI hardware history. And it would have really fed this narrative that NVIDIA is just buying up any potential challenger.
And that $20 billion figure, it certainly did its job of grabbing headlines and fueling that speculation of a massive corporate takeover.
But that's not what happened.
No. When you actually read the company's statements that came out after, the arrangement is much more nuanced. And frankly, it's a strategically smarter move than just an outright purchase.
So what is it?
It's structured primarily as a non-exclusive technology licensing agreement.
A non-exclusive license. Okay, so that's a critical distinction. If it's not exclusive, why the perception of such a high value? Why would NVIDIA commit so much for tech they don't even fully own, especially when that initial number suggested a total buyout?
Well, it comes down to two things: speed and specialization. NVIDIA already has the dominant platform, no question.
Right.
But they must have seen a performance gap for certain very specific, highly optimized inference workloads. And that's a gap that Groq's architecture was uniquely built to solve.
So instead of spending years trying to build it themselves,
They license it. A licensing deal gives them instant access to the intellectual property, the IP. They need to close that gap almost overnight.
and it avoids all the headaches of a full acquisition.
All of them. You skip the lengthy regulatory reviews, the messy integration problems, the corporate culture clashes. A full multi-billion-dollar buyout is a massive undertaking.
It's a huge management distraction.
It is. This approach lets them surgically extract Groq's key innovations, plan them into their own future hardware, and they don't have to deal with Groq's ongoing operational costs. Or, for that matter, the antitrust scrutiny a $20 billion takeover would definitely attract.
That distinction is so important that it's licensing for a specific capability, not an acquisition for total control.
A surgical strike is a good way to put it.
And beyond the IP, the deal also involved people, which, that often tells you where a company is really focused.
Absolutely. The talent acquisition can be just as valuable as the tech, sometimes more so. And this arrangement specifically included bringing over senior executives.
Most notably, Jonathan Ross, Groq's founder and CEO.
The founder himself now joining NVIDIA. This tells you it's not just about buying blueprints, it's about recruiting the architect. When you bring the mind that designed a cutting-edge architecture into your own team, you're not just getting the tech. You're getting the forward-looking expertise for what comes next. It's an immediate boost to NVIDIA's internal engineering team focused on high-efficiency deployment.
So if Ross and other senior leaders are heading to NVIDIA, what's left of Groq as a company? Does it just kind of fade away?
Well, based on the disclosures, Groq is set to continue operating independently just under new leadership.
Okay.
And that's a really key part of this non-exclusive model. NVIDIA gets exactly what it needs, the specialized IP and the top talent, but Groq remains a functional company. It could, in theory, continue to innovate or even serve other customers.
But its strategic core, its creator, is now inside the market leader's tent.
Exactly. The original company is still there, but its most valuable strategic asset has moved.
Which brings us to the technology itself. The reason Groq was a target in the first place, regardless of how the deal was structured, the whole conversation was about AI inference. We hear about AI training all the time, but for anyone listening, let's just clearly define inference and explain why it's creating this sense of strategic urgency.
It's essential to ground the whole discussion in those two phases. Training is that first step. It's the huge, upfront computational job,
Heavy lifting.
the heaviest. You're feeding a model petabytes of data, sometimes for weeks or months, to teach it how to function. This is a massive capital expenditure capex to build the compute clusters, and NVIDIA's dominance has really been built on winning this phase.
Right, the massive upfront cost to create the model in the first place.
Exactly. Inference, on the other hand, is the second phase. It's the immediate real-time execution of that model you just trained.
It's what happens when I ask my phone a question.
It's what happens every single time. Every chatbot query, every time a self-driving car processes what its sensors see, every Netflix recommendation, you're running the model to get a result.
Yep.
And because this is happening constantly for every user all over the world, inference is the dominant and growing operational expenditure, the OpEx of the entire AI era.
And the scale is just completely different. A training run happens once, maybe a few times for updates. But inference happens billions of times a day.
The difference is astronomical, so any optimization you can make there has a massive and immediate effect on your profitability.
Right.
While training determines your initial hardware purchase, inference determines if your AI service is even economically viable in the long run. If you can make inference just, say, 10% more efficient, you're talking about billions of dollars saved in electricity, in data center footprint, in better response times for users.
So Groq, with its architecture designed specifically for this execution phase, was just too important for NVIDIA to ignore.
They had to make a move. They needed to ensure their platform remains the leader, not just in the capex of training, but also in the opex of inference.
So this whole arrangement, it really confirms that the market's attention is moving.
It's a pivot, absolutely. We're going from that initial land grab for training power to the much more sustainable long-term problem of deploying these models at a massive scale. The market seems to be saying that the architectures for training are, well, pretty mature. The real competition now is about how to run them efficiently.
So the blueprint for making a big model is pretty well established. The new competitive front is all about the efficiency and the economics of actually operating it once it's built.
That's the heart of it. The training problem is resource-heavy, but it's finite. The inference problem is perpetual. It scales with every new user you add. And what we're seeing is that the market has really zeroed in on 3 core metrics for inference optimization.
Okay, let's break those 3 down because they really define the requirements for all the infrastructure companies we're going to talk about.
The first one, and it's the one users notice most, is latency.
Response time.
Exactly. The delay between when you ask a question and when you get an answer. For things like conversational AI or financial trading or autonomous vehicles, latency is everything. It's a measure of quality and, in some cases, safety.
Yeah, if a chatbot takes too long, it's annoying.
Mm-hmm.
If a car's computer takes too long, it's dangerous.
Precisely. And if you can get that response time down from, say, 200 milliseconds to 20, the entire user experience is transformed. And getting that kind of low latency, it's not just about having a fast chip. It demands very specialized memory architectures and logic units that can run all the math in parallel without any bottlenecks.
It's the difference between a fluid, real-time conversation and that awkward pause while the AI is thinking. And I'd imagine that puts a huge strain on the connection between the processors and the memory.
A monumental strain. That speed of data retrieval is critical, which leads to the second metric, cost per query.
The bottom line.
This is the ultimate business metric. It's the cost in both compute time and energy to generate one single output, one sentence of text, one generated image, one decision.
So if one company can serve a query for a fraction of a cent, and their competitor is stuck at 5 times that cost.
That first company has a massive strategic advantage in their pricing, in their ability to scale, in penetrating the market. The whole hunt for better inference tech, like Groq's, is really a hunt for better margins and bigger scale. It's where the money spent on training finally has to prove its worth in the real world of OpEx.
And tied directly into that cost is the third metric, which is power efficiency. And that's about more than just the electricity bill.
Oh, much more. Power efficiency is obviously tied to the economics, but it's also constrained by the physics of a data center. The amount of energy these huge inference clusters draw determines everything.
Like where you can even build the data center.
Right, and what kind of cooling you need. If you have an architecture that can do the same job with much less electricity per query, you free up power for other things, you lower the heat, and critically, you can pack more computing power into the same physical rack space.
Power efficiency is becoming the hard ceiling on how much AI we can actually deploy.
It is. It's becoming a major competitive lever.
So with that in mind, NVIDIA's reasoning for getting this tech becomes very clear. They want to win on all three fronts: fastest, cheapest, and most power efficient. Can you expand on how folding in Groq-style technology strengthens their already powerful position?
The goal here is pure platform defense and expansion. NVIDIA wants to reinforce what the market calls its end-to-end platform.
And that's much more than just selling chips.
It's an entire ecosystem. It's the specialized hardware, the GPUs and other accelerators. It's their high-speed networking gear, like InfiniBand. And most importantly, it's the software layer that ties it all together, which is CUDA.
We hear about CED all the time. For anyone listening who isn't deep in the software side, can you just explain why CEDA is such a powerful advantage for NVIDIA and how this move reinforces it?
CUDA is NVIDIA's crown jewel. It's their secret weapon. It's a parallel computing platform and a programming model that they have been building and refining for more than a decade.
So there's a huge legacy there.
A massive one. An entire generation of AI researchers, developers, and engineers has standardized their work on CDA. Every major AI framework, every complex model, all the optimized code, it's written to run best on CDA-compatible hardware.
That sounds like an incredible barrier for any customer who might think about switching. The cost must be immense.
It is. It's a software moat that would take a competitor years and billions of dollars to replicate. So if, say, AMD comes out with a chip that's theoretically faster, a customer still has to go through the pain of rewriting or re-optimizing their entire software stack to even use it.
And this transaction just makes that moat wider.
It does, because it shows that NVIDIA can acquire and integrate world-class inference tech and make it work perfectly within that existing trusted CEDA ecosystem.
So a customer who trained their model using the CDA stack now knows that the most efficient path to actually deploying that model is also on the NVIDIA platform.
Right. It guarantees them the best performance across the entire lifecycle of their AI model.
So the strategy really has two functions. It keeps them ahead on the technology, and it also walls off competitors from getting a foothold in inference, the fastest growing part of the AI compute market.
That's it, exactly. All the data points to inference demand continuing to grow exponentially. It's going to dwarf training demand in terms of sheer volume.
And if a competitor managed to get a clear lead there,
It would be a problem for NVIDIA. If someone could offer a much better cost per query, for example, they could eventually convince the big cloud providers to redesign their data centers around a different architecture. That would threaten NVIDIA's whole model.
so by getting Groq's IP and talent, they're proactively shutting that door. They're making sure their platform remains the default standard for both the initial build-out and the long-term running costs.
It's a classic platform defense play.
Okay, we've laid out that this move is all about cementing the NVIDIA platform and winning the race for inference efficiency. Now let's look at the knock-on effects. Who else in the supply chain stands to gain from this consolidation? We can break them down into a few categories.
Let's start with the most direct beneficiaries, the companies that gain from the standardization of the compute platform itself.
This first category, let's call it AI compute platform leaders. It obviously starts with NVIDIA, ticker NVDA, but it also includes ARM Holdings, that's ARM. And the logic here is all about that reinforcing cycle of platform lock-in.
Right. When NVIDIA adds this advanced inference capability, they're basically patching a potential weakness in their future plans, and that instantly makes their whole platform stickier.
The big customers, cloud providers, large enterprises, they're making huge, decade-long bets on this infrastructure.
Multi-billion-dollar bets. And they need predictability, they need efficiency, and they need a performance roadmap they can count on.
And a platform that's now demonstrably better in both the upfront CapEx phase of training and the long-term OpEx phase of inference. Well, that makes the idea of switching to an unproven alternative look much, much riskier.
That is the key financial driver. The whole value proposition is that seamless full-stack deployment. You get the hardware, the CUDA software, the system integration, all from one place. By solidifying their inference story, NVIDIA just accelerates the whole adoption cycle for their hardware. They maintain their volume and, crucially, their pricing power.
So let's talk about ARM Holdings, ticker ARM. Their role is a bit different. They license the underlying IP. They don't sell the final accelerator cards. How does an NVIDIA move like this help ARM?
ARM is the foundation. Their chip architecture is the basis for almost all advanced AI silicon designs. That includes parts of NVIDIA's accelerators and also the custom chips that the big cloud companies are developing.
So they're kind of like the bedrock of the whole industry.
A good way to think of it. So when a major market event like this happens and it speeds up the overall pace of spending and development in AI compute, ARM just naturally benefits from more licensing fees and more royalties.
So it doesn't really matter to them if the market consolidates under NVIDIA or if challengers are forced to innovate faster. The net result is just more complex, powerful AI chips being designed and deployed.
Exactly. Any event that increases the velocity of investment in the advanced compute world is a good thing for ARM. They are the foundational IP provider for that entire ecosystem. They win because the total market for high-end AI silicon is just getting bigger faster.
Okay, let's move down the supply chain. If inference demand accelerates, then the physical data centers have to be built out faster.
That's the immediate consequence. This infrastructure segment, the picks and shovels of the AI gold rush, is a clear beneficiary. Here we're looking at companies like Arista Networks, ticker ANET, and Supermicro Computer, SMCI.
And the logic is simple. If the tech is better and cheaper to run, more people will use the service, and you need more physical gear to handle that load.
It's a direct link. If inference demand grows, data centers have to deploy more of these high-density accelerator nodes. That means they need more specialized servers. And that's where a company like Supermicro, SMCI, really comes into play. They specialize in these high-density systems that are engineered to pack dozens of these powerful hot accelerators into a very small space.
We're not talking about your standard office server here. These are machines built to handle extreme heat, often needing things like liquid cooling.
Absolutely. The efficiency gains from optimized inference are great. They reduce power per query, but you still need incredibly powerful and dense deployments to get the latency down and handle the scale. So this demand for specialized high-wattage rack solutions plays right into SMCI's core business. They're set up perfectly for the physical rollout of these inference clusters.
And once you pack that much computing power so tightly together, getting the data to move between all those chips becomes the next big problem. And that leads us to Arista Networks, ANET.
Right. The move from general-purpose servers to these specialized AI clusters puts a huge strain on the network. High-speed inference requires massive parallelism. You have hundreds, maybe thousands of these accelerator nodes that all need to talk to each other at the same time with almost zero delay.
Your standard enterprise network just can't handle that.
Not even close. So ANET benefits because the demand for their ultra-high throughput switching gear goes up. We're talking about switches that can handle 400 gigabit or now even 800 gigabit speeds. They're engineered for the specific traffic patterns you see in AI workloads.
So anything that speeds up the build-out of these big AI clusters is just guaranteed demand for high-performance networking suppliers like Arista.
Correct. They're essential. You need their gear to make sure the data flows fast enough to keep these very expensive, very optimized inference chips busy.
Okay, our last category of beneficiaries gets into the real physical constraints of performance: memory and data movement. The most efficient processor in the world is useless if you can't feed it data fast enough.
A critical point. This includes Micron technology, ticker MU, and Marvell technology, MRVL.
And this kind of debunks the idea that just making the chip more efficient solves every problem, isn't it?
It does. Because inference at scale means you have to load enormous models with hundreds of billions of parameters into or very near the processing unit, and the speed of that data transfer is limited by your memory bandwidth.
This is where we hear about high bandwidth memory, or HBM. It's very different from the standard DDR memory you'd find in a typical computer.
Totally different. HBM is specialized memory that's stacked vertically and placed incredibly close to the accelerator chip. It offers vastly more bandwidth than traditional memory, and you absolutely need that high bandwidth for fast inference to make sure the processing cores are never waiting for data, but it's also very complex and expensive to make.
So how does Micron MU fit into that expensive picture?
Micron is one of the key suppliers of HBM, and when inference becomes more efficient, like with the Groq technology, it actually increases the return on investment for deploying this expensive high-performance memory.
So, a bit paradoxically, making inference cheaper to run actually drives the need for more costly components elsewhere in the system.
That's the economy of scale in AI. Because this transaction reinforces the overall market for accelerated computing, it just increases the total amount of HBM needed in the world. NVIDIA's success pretty much guarantees demand for the specialized memory that Micron makes.
Which brings us to Marvell technology, MRVL. in this context.
Right. Their benefit here comes from their expertise in connectivity. They make the specialized interconnects, the sort of digital glue that holds all of these high-speed components together, both inside the server and across the entire cluster.
They're the ones making sure the data can travel at the incredible speeds demanded by the HBM and the accelerator chips.
Precisely. As inference scales up and latency demands get tighter, you need more specialized chip-to-chip interconnects, high-speed switching components, and silicon design just to manage data flow. Marvell's portfolio is built to meet those high-bandwidth needs. They benefit from the sheer complexity of the infrastructure that this kind of inference optimization requires.
All right, now we have to look at the other side of this. Whenever a market leader strengthens its position and raises the performance bar, it automatically creates some pretty tough challenges for other companies.
It does. The increased strength of the NVIDIA platform, especially in that high-volume OpEx phase of AI, just makes it harder for anyone trying to compete with the existing market structure.
Our first category here is the most direct competitors, the other data center accelerator vendors. We're talking about Advanced Micro Devices, ticker AMD, and Intel Corporation, INPC.
Their challenge just got harder. NVIDIA has now extended its perceived performance lead beyond just training and deep into real-time execution or inference.
And the whole story for challengers like AMD and Intel was about offering a compelling alternative, right? Maybe on price, or for a specific type of workload, or with a more open software approach to get around that CUDA moat.
That was the pitch. But that pitch becomes a lot harder to make if NVIDIA can now offer superior performance across the entire AI workflow from start to finish.
So what does that do to their ability to actually gain any market share?
It makes it much harder to win what are called design slots.
Okay, what's a design slot?
A design slot is a huge win for a chip company. It's when a hyperscaler or a big enterprise commits to building out their next generation of infrastructure around your specific accelerator.
So when AMD or Intel go to pitch their products, they have to convince these customers that the performance they offer is worth the massive risk and effort of using a non-standard platform.
And that business case just got a lot weaker. If the NVIDIA platform is already trusted for training and now it has this newly integrated superior inference performance, why would you take the risk on an alternative?
The decision makers at these companies, they prioritize predictability.
And end-to-end performance. The combination of NVIDIA's established CUD software and now top-tier inference hardware just raises the barrier to entry for everyone else and makes it incredibly difficult for AMD and Intel to win those big standardization deals they need to get the scale required to really challenge NVIDIA's position. They're not just fighting a hardware gap anymore, they're fighting an ecosystem gap that just got wider.
Okay, the next category under pressure are the companies who specialize in bringing AI compute to the device itself, to the edge or the endpoint.
Right, this includes companies like Qualcomm, ticker QCOM, and NXP Semiconductors, NXPI.
Now, these companies focus on things like phones, cars, IoT devices. So why would a stronger cloud inference capability running in a data center put pressure on a chip that's inside your car?
It's because of the dynamic nature of where AI work actually gets done. You can think of it as part of a potential NVIDIA everywhere strategy. As cloud-based inference gets faster and cheaper, the need to run certain complex AI tasks locally on an edge device starts to go down.
Can you give us an example of that?
Sure, think about an advanced AI assistant or a really complex image recognition task on your phone. Right now, your phone might run a smaller, less powerful version of that model locally to keep the response time low.
To avoid that lag.
Exactly. But what if NVIDIA's new tech drops the cloud inference latency to a nearly instantaneous level, say 20 milliseconds? Suddenly, the architectural complexity and the power you need to burn to get that same performance on the device, it becomes harder for a developer to justify.
It's just simpler and cheaper to send the job to the highly optimized cloud cluster.
It often is. So the acceptable threshold for cloud latency is dropping, and that lowers the pressure on customers to invest in super high-performance AI chips at the endpoint, at least for some applications.
So stronger NVIDIA cloud inference just expands the market for this centralized cloud model.
It does, and that puts more competitive pressure on edge players like QCOM and NXPI. It forces them to accelerate their own roadmaps to make sure that the advantage of local processing stays compelling enough to be worth the extra cost and complexity for device makers.
Our final category of companies facing pressure are those whose business model relies, at least in part, on customers looking for an alternative to NVIDIA.
These are the companies that help the big cloud players design their own custom silicon, their own chips. This would include Broadcom, ticker AVGO, and once again, Marvell Technology, MRVL.
Okay, this is tricky because we listed Marvell as a beneficiary earlier.
It's a complex spot to be in, and it's important to understand their dual position. As a beneficiary, their interconnect business loves the scale of NVIDIA's build-out, but as a company facing pressure, their custom silicon and ASIC design services are exposed.
The idea here is that the big cloud companies are trying to build their own custom chips, or ASICs, to get away from NVIDIA's high prices and diversify their supply chain.
Exactly. And Broadcom, AVGO, and the custom chip division of Marvell, they are key enablers of that process. They provide the expertise and the building blocks for these large customers to create their own bespoke AI accelerators.
Any move by NVIDIA that makes their own integrated platform even better reduces the urgency for customers to go down that custom route.
It absolutely does. Building a custom ASIC is a multi-year, multi-billion-dollar project. It takes a huge amount of engineering talent, and it comes with a lot of risk.
And if the dominant platform is suddenly much more efficient, especially in that OpEx-critical inference phase, does the whole risk-reward calculation for building your own chip change?
It has to. If NVIDIA, by integrating Groq's IP, can deliver performance that's just as good or even better across that whole workflow, the business case for sinking all those resources into a custom solution starts to look a lot weaker.
So this puts pressure on a major part of Broadcom's business and a key segment for Marvell, both of which rely on big customers wanting an escape route from being dependent on NVIDIA.
The stronger the NVIDIA stack becomes, the less compelling the custom alternative looks.
So Marvell, MRVL, is really a perfect example of how interconnected this whole market is. Their interconnect business gains from NVIDIA's expansion, while their custom silicon business faces headwinds from that exact same expansion.
It really illustrates that in a market like this, the outcomes aren't simple. It's often a complex balancing act that depends entirely on a company's specific mix of products.
So we've walked through the different layers of this reported arrangement between NVIDIA and Groq. I think the critical thing for you to take away is that this is a strategic move by NVIDIA to reinforce its full-stack dominance. And it's aimed specifically at the efficiency and speed of running AI models in real time, that stage we call inference.
It really confirms that the competitive landscape has moved to operational economics. The winners in this next phase of AI are going to be the companies who can optimize that real-time user experience and at the same time drive down the long-term operational costs of deploying their models. By integrating this inference technology, NVIDIA is just raising the performance bar for the entire industry.
And to leave you with one final thought to consider, based on what we've talked about. Think about how this intense focus on latency, cost per query, and power efficiency might reshape how data centers are designed and financed around the world over the next year. If operational efficiency is truly the new key metric for success, how quickly will we see global infrastructure investment pivot away from more general-purpose computing solutions and toward these highly specialized, high-density, and intensively cooled AI systems?
That move from general multi-purpose computing to specialized, highly efficient AI execution is going to drive enormous purchasing decisions for every major tech company in the world.
And just before we finish, a mandatory word of caution. The content discussed here, which referenced companies with the tickers NVDA, ARM, ANET, SMCI, MU, MRVL, AMD, INTC, QCOM, NXPI, and AVGO, is purely the opinion of the author of the material provided. This is not financial advice, and it is not a recommendation to buy or sell any security. We strongly urge you to conduct your own comprehensive research before you make any investment decisions.
Thanks for joining us on Breaking News to Trading Moves.
Until next time.